Hello and welcome to Organic Chemistry Review presented to you by Science Visualized. Now the question here says, provide a product of the following reaction. In the first case, you have a nitrile, the CN, that's C triple bond N, reacting with water under acidic conditions. And the end result is that you end up forming a carboxylic acid. So that carbon that had nitrogen becomes carboxylic acid. The second question starts with a nitrile, but now we are using a Grignard reagent, which gives R minus nucleophile, CH3CH2 minus nucleophile, and that will connect to the nitrile carbon, and then you end up with a ketone. So the product will be that carbon becomes a ketone, and now you add the alkyl group from the Grignard, which is CH2CH3. Next question is called Wittig reaction. It's spelled this way, W-I-T-T-I-G. And basically what happens is that the carbonyl is cleaved at that position and then connected to this alkyl part, and you end up with an alkene. So this is called Wittig olefination. So you end up with what you're starting with on the right hand side, and then the double bond now becomes an alkene, and then you end up with this other section, and that becomes the product. Number 4, we're starting with a ketone, reacting that with an amine, and if you look at this amine, that nitrogen has 2 hydrogens, so that's a primary amine. Anytime you react a carbonyl with a primary amine, you end up with what's called an imine. An imine has carbon double bond nitrogen. So it's almost like an alkene, but now the double bond is to the nitrogen. So you end up with that ketone part, but now you have double bond nitrogen, and then you include this other alkyl group, and that's called an imine. The last reaction is what we call alpha beta unsaturated system. And if you look at this system, the oxygen can be labeled as position number 1, and then 2, 3, and 4. Anytime you have an alpha beta unsaturated system, the nucleophile can either add to position 2, so right there, to give you an alcohol, that's called a 1,2 addition, or it can add to position 4, and that's called a 1,4 addition. 1,4 addition results when you use what's called a softer nucleophile, while 1,2 addition when you use what's called a harder nucleophile. Now let's look at what we have here. We have alkyl lithium. That's actually a harder nucleophile, but anytime you add copper, so this is copper iodide, so any type of cuprate, CuI, CuI2, CuCl, CuCl2, CuNO3, any type of copper salt, then that will change a harder nucleophile to become a softer nucleophile, and therefore you end up with a 1,4 addition. So let me show you what's happening by first of all redrawing the back what we're starting with, and then we still have that carbonyl, but now because we are adding the alkyl group to the 4 position, so here we end up adding the alkyl from the alkyl lithium CH2, so from here CH2 CH3, and then this double bond moves to this position, then you end up with a double bond there and a minus here, and then eventually when you work up the system, you add water or protons or acid, then that becomes an OH, and then it becomes what's called an enol. Then you get what's called keto-enol tautomerism, where now that double bond moves here to become a double bond, and therefore the final product will be, so that becomes a carbonyl, and now you have the nucleophile added to the 4 position. Thank you very much for your time. If you enjoyed this presentation, please support the channel by subscribing and also by liking the video. Bye.